Okay, hi girls. So this is the last video I'm going to make in this little first introduction into space and how you can use mathematics in space and the equations associated with space. Okay, so we're going to talk about escape velocity. Continue on from what I was saying about that. We're going to talk about interstellar travel and how we do that. So how we travel throughout the stars. Okay, so we spoke about the equation for escape velocity, and this is where you can escape off a planet, the gravitational pull of the planet, and you can travel throughout space. Now, we spoke earlier on about how space is a vacuum. Okay, that's the first point. The second point was we spoke about Newton's law, which said that if you push an object, so we've got a rock here and you throw it. If you throw it in space, it's never going to slow down until it hits something, because it's a vacuum. There's nothing acting against it. If you throw a rock on Earth, eventually it's going to fall because there's wind and there's everything that's going to act against it to kind of push it down. But in space, if you throw a rock, it's just going to keep going and going and going. Now, the advantage for interstellar travel, which is traveling throughout the stars, is that once you do escape the gravitational pull of a planet, you can turn off the engines, and whatever direction you're pointed in, the spaceship is going to keep going in that direction. Okay, so that's really, really cool. The only thing is, if you want to change direction or if you want to speed up and slow down, you're going to need a lot of fuel to do that. Okay, and you know, I don't know if you've seen the size of the universe, but it's pretty big. It's at least twice the size of London. So, you know, you're going to need a lot of fuel if you want to just keep using fuel to travel throughout the galaxy and the solar system. So instead of using fuel to travel and speed up and slow down and change direction and all of that, what they use instead is called gravity assist. Okay, now this is possibly the coolest thing I have ever seen. You know that part, I don't know if you've ever seen Armageddon, where they say that they're going to, you've got the Earth and you've got the Moon, and then you've got this like asteroid that is coming to destroy the Earth. What they do is they take off the Earth and they fly up and they go into orbit, they escape the velocity of the Earth, and what they do is they slingshot around the Moon, okay, and they use the gravity of the Moon to speed up and shoot them in the right direction. Okay, so they come around here and then they get the gravity of the Moon and then boom, and they accelerate and then they land on the asteroid. Okay, now there's a load of equations and lots of maths involved in working out where the Moon is going to be, where the asteroid is going to be, in order to slingshot around and land on the asteroid. But it's really, really cool. The two most successful and coolest operations that humans have ever done using gravity assist, I think, is the Voyager program. Okay, so Voyager set off in the 1970s. Okay, you had Voyager 1 and Voyager 2. And both of them have travelled all across the solar system, so all the way past Pluto, and it was so successful that they just kept it going. And so far, Voyager has travelled 7 billion kilometres. It's currently out in the